So, my name is Mark, and I am based at the University of Liverpool. I'm based in what we call the Geographic Data Science Lab, which is a research group of people who are just interested in quantitative methods and trying to look at spatial processes, whatever they are. What I'm presenting today is some work that's come out of the lab, but also involving colleagues in public health and infectious diseases at the University of Liverpool. That was funded by the NIHR, which is a funding organisation in the UK. Specifically, this piece of research was funded in response to the initial first wave of COVID-19 many, many years ago. It almost feels like a long time ago, but last year. And specifically, it's kind of just focusing in this case around how misinformation reacted to the first UK lockdown. So specifically, what we're going to go through today, we're going to talk a bit about misinformation and why it's really important for understanding this pandemic. I'll talk a bit about the data sets that we've used, and we'll have a look at some of the trends in misinformation pre and post that first lockdown in the UK, as well as different types of misinformation that might have been floating around at the time. So what's the problem that we're interested in? Well, public health crises, and going back quite far in the past, often have misleading or inaccurate information shared with them. And we can go as far back as the Spanish flu, the sort of last massive pandemic, in which there was a lot of information being shared around that it was either wasn't something to worry about, that it wouldn't kill people, that advice things like masks and social distancing, which are really the same things that we're promoting today, weren't particularly effective at reducing it. And this were pretty devastating, the effects, and a lot of people died really as a result of this sort of misinformation back then. But we see the same parallels of what we saw in 1918 today, really, and a lot of this misinformation still circulating, just in very different forms. Indeed, this world is a very different one to the one back then. But many of these old problems really just have a new angle in how they are being circulating. Indeed, you might even argue that things are a lot worse now because things like smartphones and social media mean that we have information is much quicker to be shared across people, across networks, and that it reaches a much greater global audience than it would have done in 1918. So this close connectivity of humans through technical networks, whether that's on their smartphones, on their computers, through social media, the internet in general, means that we just have much more information and access to information than we've ever done in the past. And what this means is there's a lot of unofficial and official information circulating at the same time, which compete against each other for our attention. And this is all within a sphere that is, unregulated. There's a lot of information going around. People can just put views out there, and it's not necessarily always challenged. So we've got this source of information circulating, and at the same time, we're increasingly using the internet and going to the internet as our almost first port of call for health-related information. The so-called sort of Dr. Google effect, where people will Google symptoms or they want to keep up and abreast of situations. And of course, when you've got a fast-moving pandemic, we're constantly looking for that next news source, that next bit of information. How are things going to go? And of course, that means there's opportunities for these official and unofficial sources of information to catch our attentions. So what are we interested in particular in this talk? Well, we're really interested in this vague and general topic of misinformation. So what do we mean by misinformation? Well, what we're going to treat misinformation as in this talk is just any piece of information. Now, it could be news, it could be rumor, it could be an official or unofficial source. It's something that is misleading, inaccurate, or false. Now, we're not going to talk about the nature of whether that information is being shared with intent to cause harm or not. So if there is a distinct way that information is being created and shared to cause harm to others, then we might say that's disinformation. We're just going to focus on anything that we think is misleading or just simply not true. Now, to give a bit of context to the extent of misinformation going around, there's a wonderful survey run by Ofcom, which is a UK organisation that does a lot of information and gathering around TV and the internet. They have a range of responsibilities, but they've been running these monthly surveys, just talking to people and asking people about their experiences gathering information, including misinformation. Very early on in the lockdown, from post-lockdown in the UK and early on in the pandemic, quite a lot of people had actually seen some sort of form of misinformation. And indeed, Ofcom was saying roughly about half of adults they were surveying had seen some form of misinformation, and indeed had seen more likely to have seen it on social media than in other sources as well. About 3 in 10 people using social media as a key source of information. The most trusted source of information often was TV or through the local for government or trusted main newspapers, but still a lot of people getting their information from social media. So we do know that there's a lot of misinformation circulating around in the pandemic, but also it's worth noting that a lot of people, when we survey them, essentially know what misinformation is, or they have an idea what it is, and they kind of feel like they know how to deal with untrue stories. So whilst there might be a lot of misinformation floating around, it's sort of unknown what the impacts of this are. What types of misinformation might we be experiencing COVID-19? Well, there's a whole range, and there's sort of 4 main themes. Specifically, quite early on, I think we've seen a lot of stuff around cures, treatments, what works for helping COVID-19, and of course things like chloroquine and variants of those types of medicines have been really flouted, and indeed in the news today again as something that can cure COVID-19, often perpetuated by the then US president. And indeed, these things have real world effects. So something like hydroxychloroquine, there's evidence that because that's an effective treatment for things like rheumatoid arthritis, people who are suffering from that have experienced delays in accessing their treatments. Other people were hoarding these drugs because of what they saw in the news. There's a lot of stuff around causes, origins, and mode of transmission of COVID-19. Probably the most popular one, unfortunately, happened here in Liverpool. Obviously, there's a lot of talk about 5G sensors causing COVID-19, and indeed, in Liverpool, some very smart cookies set fire to a 5G telephone mast, a couple of miles from my house, to try and deal with it very early on in the pandemic. Obviously, probably the most prevalent thing at the minute is the anti-vaccine movement, which is very popular on social media. But also there's more broader social impacts of COVID-19, things like panic buying toilet roll, or even in the Ukraine where there was a huge amount of rioting over one social media post around evacuations of people from China early on in the pandemic. So there's a big issue around misinformation. But of course, these things don't happen in isolation of how we respond to the pandemic. And of course, UK government, but also like many other governments, have been, deploying very different approaches to try and dealing with the pandemic, particularly very uncertain. We're not sure what to do with this. It's not something that happens very often. And when there's a huge amount of uncertainty that might also be playing off some of this information, misinformation might be thriving where there's a lot of uncertainty. Really, the important thing is that public health communication needs to be clear, it needs to be consistent, and it needs to be frequent enough. Many many different governments across the world went about this by doing daily briefings, so just getting the key information out and putting these on main media platforms and indeed social media to just try and communicate and avoid any confusion, really push out the key messages again and again. But of course, the government tries its best, or at least I hope it tries its best, but misinformation might disrupt or harm some of these communications, particularly presenting uncertainty in these messages, And it might then have further implications down the line, whether there's lower trust in politicians, or whether people start to resist these public health messages because they've seen other things on social media. Now, what we probably think about now is that we have a lot of research that tries to characterize what misinformation is, how it spreads, but how it impacts on public health and public health behaviors isn't necessarily always well understood. Particularly very early on in the pandemic, we were probably playing catch up very much to try and understand what was going on. And in particular, because we have very poor understanding of what's going on, um, we didn't necessarily always have effective strategies to tackle this. And indeed, we probably still don't have that effective strategies. Social media firms probably can do a lot to tackle it, but don't always. And then these things start to work. Now, we know that people react to policy, they react to different types of policies depending on their own personal beliefs. And of course, so we might see some of these similar parallels to how people react to misinformation. Misinformation is powerful because it plays on our emotions. And indeed, it can be really deceitful when combined with some sort of plausible message or even some sort of pseudo-scientific study to go along with it. And of course, our reactions to policy, again, often play on our own emotions. Something like a lockdown is quite severe, and people sort of talk about taking away liberty, taking away your freedoms. That you can see how people will react very similar to this. But COVID-19 is also not going to probably be our last pandemic. There's probably going to be other pandemics or other epidemics. So really now is a good time to start to take stock over how we've responded to this and start to evaluate how we can do things better in the future. So we have said about this study at a time when really we didn't know exactly what was going on. We started it last April, May onwards. And of course, there was a lot of good COVID-19 misinformation research, but some of it was quite descriptive at the time, really just describing what misinformation was out there. And really, we want to be able to combine these things and try to understand, well, how do we respond? And can public health communications play an important role in this? So, the aim of our study was to examine how trends in misinformation react to a major government policy announcement during a public health crisis. In this case, we decided to take the UK's first lockdown, which happened. It was announced on television on the 23rd of March, 8 o'clock. And we decided to pick this because it was a huge thing that hadn't really been done before. And we wanted to pick a specific event to see how misinformation reacted to. Others might say that we picked a particular time frame because the amount of data in social media sometimes makes it very much unmanageable, and at least this way gave us something that was a bit more focused to focus on, but we'll ignore that for now. So what data do we use? So we use Twitter data. Why do we use Twitter data? Well, to some extent it's accessible. They make it available to researchers. Back then we had extra money to get to the fancy premium API, but nowadays you can get better access as a researcher for free, and other social media platforms are much more restrictive in what you can get access to. But it's also quite useful because it's a whole social media platform in which people can post short messages or tweets, and they can interact with others and other tweets on that platform. So it gives us an insight into how do people react and respond to information. To do this, we decided just to focus on that key policy announcement on the 23rd of March. And we decided to focus on things happening 48 hours before and 48 hours after. The decision to go for 48 hours, while somewhat arbitrary, was so that we could focus on the immediate response to the announcement, as well as knowing how things happened before that. Just to see, because that's probably a critical period that the government needs to get its message out and get that message right. And of course, if the response isn't very good initially, it could negate the whole point of that, the message. We selected only tweets from the UK. We did that based upon tweet or profile location. It's probably quite difficult to do this, so we could only really work with what best that Twitter allowed us to access to. And we also did something which I'll come back to in a bit, is we tried to identify bots from tweets. The way we did this is we used a R package called tweet bot or not, which is a way of trying to identify if users, rather than the tweets itself, the users were bots. And the classifier itself is based upon a machine learning algorithm that tries to predict whether a user is a bot or not, based upon how often they tweet, the number of followers they have, profile location, the content of previous tweets, so things like hashtags, do they have lots of capital letters in them? And the package itself claims to have a 92% accuracy, which I think is a little bit high. But essentially, we use this as just a proxy for whether we thought a tweet came from a user who is a bot or not, and we selected it based upon that. What we did is we selected all COVID-19 related tweets. We didn't focus on all tweets because we wanted to make sure they were specifically related to COVID-19. They mentioned it, which has some strengths. We know they're all about COVID-19, but of course, if I tweet about 5G masks are terrible, it's kind of indirectly about COVID-19, even if we would miss it, which again comes back to it's really difficult to measure a lot of these things. We split our kind of keywords based upon expert opinion, so talking to some policymakers, talking to academics in this field. We shamelessly stole the list that Twitter put up on their website. We also sort of went around popular terms that Twitter was talking about and profiling popular coronavirus terms. And we ended up coming with general terms related to COVID, misspellings of those common terms, things that are related to the UK specifically. And we also included derogatory terms at the time because we wanted to potentially have an equity angle to our analysis. But I won't be talking about that itself today. I think the reality is that whilst picking out COVID-19 related tweets is difficult, picking out misinformation is even harder. Initially, we sort of thought about starting with a kind of predictive model where we would be able to get some training data and predict whether a tweet was misinformation or not. But that itself is really difficult to do. So we decided just to focus on a sort of simpler approach, which was, can we identify if a tweet actually does mention a specific piece of misinformation? To do that, we ended up going on 5 fact checker websites, and we pulled out all COVID-19 related pieces of misinformation that had been fact checked on those websites up to the end of our data period, anything from the start of the pandemic. And then we could identify if tweets included or were about these websites. We also took from NewsGuard Tech a list of websites that had been identified as sharing misinformation, so not necessarily things that were always covered in the fact checker websites, but also those that were pushing out dangerous information just on their websites, not necessarily always on social media. We also picked up a list of Twitter accounts that were related either to the first two, the websites, or indeed the fact checker posts. And we also took out a list of keywords from the World Health Organization's Guide to Misinformation at the time. And what we were trying to do is essentially just pick out anything that we think might be about misinformation. The problem is that it's possibly that we're being a bit too narrow and a bit too hard on our kind of definition of what is misinformation or not, and we're probably underestimating it to some extent. But I feel like it's a sort of hard task. So if anyone's got any suggestions of how to improve that, I'm all ears. What we did with this was we decided that since we had gigabytes and gigabytes of data, the easiest thing to do is it's about making big data small, easy, and manageable to deal with. And the way we did this was by aggregating things up to hourly records, so number of tweets per hour, number of misinformation tweets per hour, number of tweets by bots per hour. And this allowed us to then have a time series study design, which would allow us to assess how the announcement affected trends. Sometimes it is about making those data sets more manageable and reducing some of that information down into something that's a bit more easier to play with. So we had a sort of natural experiment set up in that we have data beforehand, so we can understand the trend beforehand. We have an interruption, which in this case is the policy announcement, and then we can look at how it affected trends after it. There's not necessarily any gold standard or best method for doing these sorts of interrupted time series analyses. So we just ended up going with 3 methods that are used in the literature, because we thought, at least we could triangulate our evidence base and we can look at collectively whether they're all in agreement or not, rather than just picking one arbitrarily and just focusing on what that is in case it was misleading. In summary, we did a bunch of time series models to try and estimate that effect. And we also tried to classify misinformation tweets, which I'll come back to a bit later, using topic modeling approaches to just see what types of misinformation were being shared at the time. And this is all on GitHub if you want to go and have a look at the code and pull it apart, and more for that. Okay, so let's get on to the fun thing, the actual results. So this is our data set. This is just looking at time series or trends over time of our Twitter data. What we have here is we have a line plot. We have the number of tweets as we go further up. So there are more tweets as we go higher up. And we have time along the bottom axis. So we go from the start of the period all the way to the end of the period, this 48-hour period before and after the lockdown. In the middle plot is just all COVID-19 related tweets in total. The top one is misinformation, so the number of misinformation tweets. And at the bottom, we have tweets from bots. This dotted line, that's when the announcement happened. So what can we see? Well, we can see a few things. If we look at the number of tweets in particular, we can see there's a big jump in the number of tweets around the time of that announcement. Indeed, about 42% compared to 7 p.m., about 38% compared to the same time the previous day. So there's a lot of people tweeting about the announcement of the lockdown. At the same time, we see a same increase here in the number of tweets from bots. Now, of course, this might be probably picking up the way the classifier works, in that it's classifying so many tweets, and therefore it's possibly just reflecting that. Or it might be that the bots are picking up on this increased Twitter activity and responding to that at the same time. And of course, if we look at misinformation, there's kind of a peak, but there's also not a peak, not as distinct. So it's hard to really draw any conclusion from here. We can also, if we look at the number of misinformation tweets, we can see that actually it's far lower than the numbers in the other 2 plots. Indeed, we're probably seeing less than 1% of tweets overall being identified as misinformation. So we're not talking about an issue really that is dominating Twitter in that regards. What we can do is we can stick these time series data into our fancy regression models, and we can see whether that the announcement affects the trend line. In this case, our estimate, so if we're interested in the model, our estimate is really telling us, was there an effect of the announcement on the number of misinformation tweets? And we have our 3 models. The Bayesian structural time series model gives 2 estimates out, an absolute and relative effect. If we look at the negative binomial model, we can see that it's saying there's a positive association. So it's saying it's above 1. So essentially what this is saying is that misinformation increased after the announcement, and quite a big increase, up to 90% higher. But there's a huge amount of uncertainty on that model. In particular, that value could range from about 1% to over 3.5 times wider. And whilst, we might say it's statistically significant because it happens to be under 0.05, I'm a little bit more cautious about this model itself. It's not necessarily the strongest. The other 2 models, though, they suggest the opposite. They actually say that misinformation fell post-announcement. The Bayesian model suggesting a drop of about 20%, so 20% fewer misinformation tweets post-announcement, and our REMO regression essentially giving us a similar effect. And of course, those models are a bit more precise. So overall, it probably suggests that misinformation fell, but we can't necessarily always conclude that from this because not all of our models are in agreement. We can do the same for the bots as well. Remember, we could look at the number of bots that were tweeting and see whether they changed after the announcement. And again, this is a bit more messier. We can see that if we look at the p-values, our statistical significance, well, you know, two of the models, the Bayesian one and the ARIMA model, are both not statistically significant. So it suggests there was no effect. And bots were no more likely to tweet pre or post the announcement, sorry. But our negative binomial one does give us a statistically significant one, suggesting there's more tweets from bots post-announcement. So again, overall, there's probably no agreement across our models. We can try and pick this apart a bit more, this bot issue as well. In this case, we're just looking at the percentage of tweets that were identified by bots. So as we go further up, we have more tweets that were from bots. As a proportion of all tweets, and we have time again on our bottom axis, and we have this dotted line for the announcement. And what's really interesting is actually this period before the announcement where there's an increase in bot activity, almost as if that happens before the announcement, possibly in anticipation, but not necessarily always about that. And indeed, it continues post-announcement, continues actually into the early hours of the morning, and very much into the next day as well, before dropping back down to sort of normal. So it's possible that any association for bots might be a bit more subtle than really the announcement itself. We can also look at how often these tweets were engaged and shared. So we can just count up the number of times they were replied to, retweeted, quote tweeted, or favorited, just to get an idea of engagement. It's a bit crude, but it gives us an idea. If we look at the differences in tweets pre or post announcement, actually, you know, the number of shares pre-announcement was about 6 versus roughly about 5 post-announcement. If we do a t-test, as a very rudimentary way of looking at the differences, it suggests it's not statistically significant. So there wasn't necessarily any difference in tweets being more likely to be shared or not. If we look at tweets from bots, though, they were far less likely to be shared than those tweets that weren't from bots. So an average of 2.9 shares for tweets from bots versus 6.5 from those without. And that is statistically different. So it feels like it's a meaningful difference. So bots were less likely to have any engagement with their tweets. If we do the same for tweets that were misinformation versus tweets that weren't misinformation, we don't necessarily find a significant difference in their being more or less likely to be shared, although in raw terms, they were shared more than those that weren't misinformation. What we can do is we can also try to classify these tweets that were misinformation to have a look about what's going on there. To do that, we essentially do lots of different models to try and identify and describe how many clusters or topics we think are in the data. And we can do this across different types of metrics. In this case, essentially, as we go further across, we have more clusters or more topics starting at 2. So you're essentially splitting the data into 2 groups or 3 groups or 4 groups, and you keep repeating that process. On the bottom 2 metrics, we ideally want them to be higher, so higher up the graph, and the top half, we want them to be lower. So we want to minimize those values. And what we can see is actually across 2 metrics, we think about 4 clusters was best for our data. The other 2 metrics, they kind of just suggest that more clusters is better. They don't, not particularly as insightful. So if we have a look at these types of topics we identify in our tweets, we find these 4 groups, and we've classified them, we've given them general names. I've plotted here also the most common terms within each of the clusters. So we have 1, 2, 3, and 4. As we go further up, we've got more important terms, and as they go out, they're happening more frequently or more commonly within a topic. So the first cluster we found was things around government and policy, so misinformation related to that. Often it was quite emotional, quite angry. They were focused on the NHS, the National Health Service in the UK. Often they were quite critical of the government. They might blame the government for not behaving appropriately. Also, even indeed critical about China and blaming China for the pandemic came out quite a lot in this. The second one we found, we termed symptoms. This was by far the most common misinformation tweet we found. These were often tweets that were about how do you minimize the risk of getting COVID-19? What should you do if you have symptoms? They often would, people were talking about you could detect if you had COVID-19 based on the temperature of the palm of your hand. There were also tweets about individuals discussing their own symptoms or sharing incorrect information about symptoms, or indeed incorrect ways of diagnosing the condition. The third one we had, which was our smallest one, was we called pushing back against misinformation. So this wasn't necessarily always inaccurate information. It was tweets that often were pushing against it or calling it out. So it could be things like people tweeting, take the disease seriously, stay at home, please socially distance, please ignore this information, expressing some sort of disappointment about what was being shared. Now, you might think this isn't misinformation, but again, tweets that are kind of either trying to debunk or calling it out often do repeat some of this misinformation, or they might widen its circulation around. So they do have a positive role to play, but they also do contribute to some of these issues. The final one, which is probably the most worrying one, was around cures and treatments. So there's a lot of tweets around particular treatments. So often you see this second common word in there, if you can see it, is chloroquine. Hydroxychloroquine was also in there. There was talk about preventative strategies for how you can avoid not getting COVID-19. So the sixth most common term was mobile, which is a lot of people tweeting about mobile phones and 5G. Language was quite emotive, particularly more emotive than the other clusters, talking about dying, things like that. And also in the top 10 most common terms, you have Trump, which isn't the sort of flatulence term in the UK, but really is referring to the US president and the things that they were sharing. What we can do is we can actually take each of these clusters and stick them into our fancy time series models to see if any of these were affected by the announcement. It's a huge table, but I'll just draw your eyes really to the most important part of this, which is actually cluster 4, cures and treatments, which is significant in all of our regression models. Indeed, no other cluster is consistently significant. It's a bit more inconsistent, so it's harder to draw conclusions about them. But for cures and treatments, we see that no matter how we model it, we see that the number of tweets increased post-announcement. So it's almost like once the announcement is made, there's more tweets relating to these cures and treatments. And this might reflect on people maybe worrying about the extent of the lockdown and reaching for opportunities to say, well, we could just end it if we all do this, those types of tweets. And we can see this out visually as well, just plotting each of the clusters over time. The thinner line is the raw value, and then I've smoothed the lines just so you can see the trend. In this case, we're just looking at the percentage of all misinformation tweets by each of the clusters. So there's more tweets by a topic as we go further up. We have time again on our axis, and the dotted line again is the announcement. And you can see really, and indeed in the rawer line, not the thicker smooth line, you can see that rise post-announcement that goes on into the next day, and indeed it crossed into my birthday as well. So we can see that there's potentially some evidence for that, but it is a little bit more messier than the other stuff. So there's the kind of key takeaway messages from this talk. Well, I think the first one is that we can use big data to help us. We can use these large social media data sets to respond, and indeed in almost real time, we can do these types of analyses very quickly to help us understand how the social media sphere reacts to key public health communications. What we've shown, though, is there's probably no consistent evidence of increasing misinformation post-lockdown. If anything, it's possibly decreased, so that might suggest that clear, consistent public health messages are good. We might have seen some increased tweets from bots around that announcement, but of course these tweets were much less likely to be shared, so the extent of conclusions we can draw from that is a bit more mixed. And we found that the different types of misinformation really matter, and indeed those most dangerous tweets, the ones around cures and treatments, possibly announced post-announcement, and that might allow us really to focus our targeting. Now, what are the kind of limitations of this study? Well, there's a lot, let's be honest. So one is that it's just really messy to try and identify cause and effect and try and separate out that it was the announcement that affected these trends. And whilst we try to do that as best as possible, it's just really difficult to do that. Indeed, our kind of modeling approach is really just descriptive. It doesn't tell us why tweets might have gone up or down and the pathways or social networks in which they were affected. So really there's a sort of next step from this would be actually getting down to the mechanisms, the processes, and trying to get a better understanding of why they responded in their ways. Twitter itself, for better or worse, is one data set, but of course Twitter users are not representative of all social media users. They're not representative of UK users. They're overrepresented by people in professional capacity, tweeting in professional capacities, people of higher socioeconomic groups in the UK. So of course, how generalizable our results are is up for debate. And indeed, the way we've gone about trying to identify misinformation and bots is not the best, really, let's be honest. It's really hard to do that. And of course, doing that well requires much more effort, which can then make your results timely if you wanted a real-time kind of comparison. What does this all mean? Well, I guess to some extent, the answer is quite messy, but it probably suggests that actually clear and ideally regular government communications can be useful for reducing misinformation, and that we need to really act against the kind of dangerous misinformation that might increase as a result. We also do need to have a better understanding of what's going on, and in particular, the pathways through which misinformation influences or reacts to these key policy announcements, and really taking these things forward. And as this kind of field of infovalence starts to grow and starts to become really established, I'm really positive about that these things will happen. So this is the paper in particular that we talked about. And of course, if you're not sick and tired of Twitter from reading from this presentation, you can give me a follow. That'll be great. So thank you very much for listening, and I'm happy to take any questions.